Emily, were you able? I see you were able to get in. Was Robert able to get in?
I'm not sure. I haven't talked to him. Um, he
Was
saw the information though.
Did you use the link in the agenda that I sent? Did that work, or did you have to do something else?
I used the one in the agenda.
Okay. Do you need me to forward that to him, or does he have it?
He should have it.
Okay.
Yeah.
I just want to wait for a couple more minutes to see who else joins. I just sent a note to some other folks that I know had indicated they'd join. So we'll give them a few more minutes, and then David, I'll uh, make sure that you can share your screen, and you can. We'll run through our agenda quickly, and then David, you'll be able to share your screen and do your presentation. Several people have emailed me, so I'm just trying to help them get logged in.
Hey there.
Jennifer, we've got a couple other people that are trying to join, so I'm trying to help them out.
Okay, now I'm plugged in. Hi there.
I'm just trying to help a couple other people log in, Jennifer.
Yeah, we'll wait a few minutes. So I didn't get the agenda when you mailed it out earlier. Whenever you sent it out. Or maybe, I wonder if it'd be under your name instead of AZAP.
I may have sent it for
Yeah.
myself, yeah.
Finally got in. Thanks, David.
Good.
No, I didn't get it. I wonder what happened to it.
I thought I sent it to everybody. I mean, I could have mistakenly not, but I thought I did.
I missed it too, so it might have been an error.
You didn't get it, Nick?
No, I got the auto email when I responded to the RSVP, but not the one from you.
Huh. All right.
I guess I need to start RSVP.
Well, the link in there didn't work, so hopefully there's not other people who are trying to join via
Oh, yeah.
the auto link, because I couldn't get in that way. The one in the
Yeah.
agenda works though.
Yeah, I couldn't get in with the auto link either. And then the one in the agenda, I couldn't get it to open in my cell phone. I couldn't get it to copy and paste, but finally got it.
So Dave Mack, not McIntyre.
Yes.
Yes.
We'll see if we have any more stragglers coming on to join us, and then we'll go over, I'll start on the agenda and just do some housekeeping bits first, go over some of our items, and then I'll turn it over to you.
Sounds good.
So did some people try to join by clicking on the link in the invite? And that didn't work? Is that correct?
Yeah, as far as I know, the link that got sent out from the AZAEP email address was trying to open the meeting from August 23rd. So when you try to join, you just get stuck in the waiting room.
Okay.
Yeah, that's what happened to me.
Okay. Okay, that's good to know.
Okay, well, let's get started. It's almost quarter after. If we have any other stragglers, they can join us. Thank you all for coming tonight. This is our October meeting, AZAEP, our member meeting. And we have Dave Mack, who will be our guest speaker tonight. And I'll introduce him a little bit more in just a couple minutes. I'm going to Let's do introductions, which I normally forget. My name is Jennifer Jennings. I am an environmental planner at Tier Right-of-Way Services, and I am the president of AZAEP. Why don't we go through and get the rest of the board members, and then we'll get with the rest of the members. Nick?
Hey, I'm Nick Brazier. I'm an environmental planner at SWCA, and I'm the incoming treasurer now.
We're happy to have you.
Thanks.
Susie?
My name's Susie Morales with Recon Environmental, NEPA planner, and I'm the incoming vice president.
And David?
My name is David McIntyre. I am the secretary of AZAEP, and I own McIntyre Environmental LLC.
How about Amber? Either Amber is muted or she doesn't want to introduce herself. I won't force you guys to introduce yourselves if you don't want to talk. Would any of our other participants like to introduce themselves?
I'm Emily Fisher. I'm an environmental technician with Nino and More.
Welcome, Emily.
I'm Karika
Anybody else?
Bridgers.
Oh.
I'm with NYS Associates, and we do environmental compliance consulting.
How do you say your name? Karika?
Yes, that's correct. Karika.
Thank you for joining us, Karika.
Glad to be here.
My name's Lauren. I am an environmental planner for NV5, and this is my first meeting as an emerging professional.
Oh, well, welcome and congratulations. And if you would like to leave your name and information in the contact box or the comment box, so other people, if they're interested or want to get in contact with you for something, they have that record.
Yeah, sounds great.
Go and add my information here. Sorry, I can't talk and type at the same time. Okay, there we go. Anybody else want to do introductions? Anybody who's on mute and think they are introducing themselves?
Hi, I'm Gerald. I'm recently joined the local chapter. I'm a member of the national organization as well. I co-lead the Section 106 Cultural Resources Work Group with Brian Durkin. And I just, was able to make it in tonight because I'm sorry to be late. I didn't receive the link, and so I'm kind of just jumping in here now.
We were all having some troubles one way or the other, Gerald, so you're actually right on time.
Thanks.
Okay. Again, if you want to put your contact information, your name in the chat box, so if somebody wants to look you up later, they can do that. And let's see if I can share my screen. Where'd my share? Oh, there it went. So for those of you who aren't familiar with us, this is our website, azaep.org. And if you come here, you can find, oops, that was a little fast, lots of information. You can subscribe to our listserv and get our announcements and our newsletters. We have information up here on board members and kind of what we do, some of our highlights. This is an important one you may want to be interested in looking at, our job postings. Those are constantly being updated. We have quite a few listed on here, actually. Oh, wow, quite a few. And we've got information here on our Amy Edwards Memorial Scholarship, which we do every year. And we will be announcing that probably in another month or so. In the past, we have done a substantial scholarship. It's been a $5,000 scholarship. This year, it's going to be not quite that much, probably about $1,000, as we've gone through kind of the main pot of our money and we need to raise some more. So if your company is interested in donating to the Amy Edwards Memorial Scholarship Fund, we would be more than happy to take your donation and add it to that pot. That scholarship is normally announced in the late fall. It's for graduate students in environmental planning with an emphasis in the transportation field. And it's due usually the last day of December to give grad students a chance to apply after finals and whatnot. And then it's announced generally in February. If you'd like to become a member, we have information on benefits and dues, our code of ethics, our membership application over here. And just some more information on past events. You can also sign up for our meetings and pay for them online, which is, I believe, over under monthly meetings. Yep, down here. You can pay via PayPal online. You can also pay for your membership online as well. So let me find the agenda. Can you all see the agenda? I didn't hear anybody. I'll assume you can't. If you can't see it, let me know. So just some general announcements, a little bit more information about us. We currently have 236 members, which includes those under our corporate membership. We have 157 under our corporate membership, and corporate member is a company can pay and then have all of their members, or I'm sorry, all of their employees attend meetings at a membership rate. So a little bit of a savings for the employees, a little benefit for them, especially if it's a larger company. We have 27 general or associate members and 52 students right now, and about 720 listserv members. Corporate membership is $150 a year. And like I said, it allows unlimited number of employees to attend at the membership rate. And there is a current list of our corporate members.
Actually, that's not current because WSP just joined today.
Oh, okay.
So,
Cool.
Yeah.
Awesome.
Those and I emailed several. Those numbers actually have increased for the general and associate member because I emailed a bunch of people whose membership had expired or was expiring, and several have renewed. So.
Okay, cool. Good deal. Thanks, David. If you know a student who might be interested in attending, the membership is free and the in-person meetings are just $10 and includes a dinner. Talked about Amy Edwards and our job postings. We'll jump down here to the good part, our holiday party. We have reserved the lodge in Tempe for December 8th for our holiday party from 5 till 8. We had it there last year and it was quite a bit of fun. AZAEP will provide hors d'oeuvres, appetizers, and non-alcoholic drinks. If you would like to have an alcoholic drink, then that cost is on you. And we'll have some raffle prizes and raffle tickets to sell as well. If you are interested or you know someone who would be interested in speaking, please reach out to one of our members. We are always on the lookout for presentations. Gerald, I was actually thinking that we haven't had a cultural presentation in a while, and maybe you could put your feelers out to some of your contacts and see if somebody would be interested in doing one of our monthly meetings.
Yeah, we can certainly do that.
And now we will roll into our presentation for tonight. We have David Mack from Arizona Department of Transportation. He is the stormwater, I don't think this has your title in here, does it?
My title is Stormwater and SPCC Professional.
Stormwater and SPCC Professional. Well, there you go. We'll let David educate us on stormwater in Arizona, and I will stop sharing my screen and turn it over to you.
All right. Well, everybody, thank you everyone for having me tonight. Sorry we couldn't meet in person. This presentation is actually pretty good in person. I've given it a lot over the years to various organizations all across the country, and it's gone over pretty well. So we're going to learn about stormwater. We're going to specifically learn about ADOT's monitoring program in relation to stormwater and what that means to us and what we find out and what we've kind of drawn from it. So this is really a high level overview of our program, of a small piece of our program. But it's one that people really tend to enjoy because there's graphs and numbers, and the engineers in our agency tend to geek out on it. So it's kind of neat to watch that. So with that, we'll start off with this beautiful picture here. This is a nice storm crossing over I-10 and the Picacho area, just north of Tucson. And as you can see here, we've got this beautiful summer monsoon passing through. We've got all these vehicles getting wet and depositing their wonderful stuff, water droplets and whatever else that water droplet has onto our freeway. And that freeway is discharging that rainwater off to the right of way. And this little fence line right here, this is the line in the sand. This is where we have to meet compliance. In a city, you don't really see it as much, but in a highway environment in the middle of nowhere, that fence line, that's where my jurisdiction ends, and then on the other side, that's where the next jurisdiction starts. And so this line is very, very important, and especially on this particular photo, because this is the downstream side of the gradient, and about 5 miles away to the left of this photo is the Santa Cruz River. So this is what I'm trying to do is protect the downstream, the rivers downstream, the waterways downstream, but right here at this line. So all right, you don't want to work that way? How about that way? Oh, you don't want to work at all. Okay. All right, there we go. So just a quick outline of my presentation. First, we'll talk about how the roadway actually generates pollutants. We'll talk about the monitoring requirements in the program. Third, we'll talk about standards. Fourth, we'll talk about monitoring results. And then 5, we'll just have an overview of, like I said, high level conclusions of what we found and what we're trying to do about our program moving forward. All right, so how actually does the highway generate pollutants? Well, there's a lot of potential sources, but not as much as a city. We just have cars just driving from point A to point B, cars, trucks, vans, you name it. If it's got wheels and it's rolling down the highway, they're all sources of potential pollution that are being on that surface. Now, we don't have industrial operations. We don't have commercial operations. We don't have residential. We don't even have parks on our right of way. So there's no other effects of sources. So the biggest source of our contamination is always vehicles. And this diagram breaks it down pretty nicely of what that whole runoff constituent is. And as you can see, it starts mostly with the run-on. We're linear surfaces in the middle of towns, cities, middle of nowhere. Take city of Phoenix or Tucson. You've got the city on one side, you got ADOT's highway, I-10, I-17, I-19, whatever it is in the middle. And then on the other side, you have the city again. So we're just a pass through. But anything that runs on our property from the adjoining off-site property, whether it be agriculture or whether it be a city, a municipality, that gets included into our runoff calculation. The next part of this puzzle is the atmospheric fallout. Arizona doesn't rain all the time. It rains in their specific time periods of the summer and in the winter, but anytime during the day, there's atmospheric fallout. Whether there's a fire in California, a mining operation somewhere in the state next door, a dust storm in New Mexico, along with all the atmospheric pollutions that are created by cities, towns, and occupied areas, all that ultimately gets deposited on the highway. You don't think about it, it's small amounts, but it gets deposited all over the place. So when it rains, that gets washed off. There's also the atmospheric fallout during the rain event itself. So when it rains, the raindrop collects dust particles and whatever else is up in the sky, and that's got to go somewhere. So it goes also on my road and becomes part of the runoff. So who knows what's above us at that time, but when the storm comes through, it's nice and beautiful. You can see all over across the valley. So it does clean it up and it makes it nice, but it falls on my road, which is not always a good thing. The next part of the puzzle is the vehicle deposition. Now, I don't know how many times a year or a month or even a week you wash your vehicle, but if you wash it a lot, good, thank you. You're keeping your car clean, especially if you're an Uber driver. I love you guys because you guys are constantly washing your cars. But if you're a normal person like me, you're not washing them all the time. You're washing them once a quarter. That's usually what I do. So once a quarter. So in those times that I'm not washing it, the vehicle develops deposits on it and it shakes it off. Vehicle deposition, you don't really think about it, but vehicles are just like humans. They shed like you wouldn't believe. And if you've ever just watched the traffic go down the road, especially in an area where you have multiple lanes, like in the middle of Tucson or Phoenix, and you're just traveling, just look at the cars. Just look at what is going on. You'll see some very pretty cars, very nice, clean cars, very fancy cars, and then you'll see the extreme opposite. Like, how is that thing even running down the freeway? You'll see trucks of carrying various things. You'll see dump trucks, and next thing you know, there's leakage coming out its back. You'll just see so many different things, and all that stuff gets shedded all over the place. Vehicle maintenance. You may maintain your vehicle. You may spend the time and effort to maintain your vehicle, but sometimes, you kind of let it slip. And if you're constantly putting oil in it, there's a leak in your system and that's dripping all over the place. It's ultimately getting on my highway surface, which is part of my runoff. The new emerging contaminant that we're all freaking out about in the DOT world is 6-PPD. We don't have much information about it. It's still brand new. It's like PFAS, but it's more of a concern for us. But it comes from tires. Your tires are constantly driving on the road. They're constantly hitting the surface, and that friction is creating residue. You don't think about it, but as your tires wear down, every 60,000, 70, 80,000 miles, you got to replace them. Well, that rubber goes somewhere. And if you travel a lot on the highways, it's constantly rubbing off on the highways. And the major last component is actually ours, ADOT's, and our operations. That's construction, that's routine maintenance. If you hit a guardrail, not only do I have to go and fix that guardrail, but now I have metal, wood, plastic, oils and greases, antifreeze, whatever else from that accident that destroyed that guardrail all over the place. We'll just go back in and clean up the guardrail and clean up the roadway as best we can, but we're not going to clean up every last little thing. So that also gets put into the equation too. And like I said, when it rains, all that runoff goes off-site towards my line in the sand, and that's what we're monitoring. That's specifically what this monitoring program is designed to do. Now, my permit is designed to keep that runoff as clean as possible, that I'm not discharging above state limits. Sometimes that happens, sometimes it doesn't. We'll get into that in a few minutes, but ultimately all that runoff goes off-site and it goes somewhere into our rivers here in Arizona. We don't really have any lakes that stuff goes to, but rivers, and then ultimately all that discharges through our stream network into the Colorado River off on the west side of the state. Okay. So next, so this is a copy of our permit. This is our latest and greatest permit. We actually, it's been very interesting. This is our third permit from ADEQ this year. So we got a brand new permit in 2021, and they've like opened it like 3 or 4 times. In fact, right now, if you wish, you can go to ADEQ's website and comment on our brand new permit. I don't know why. I don't know what's going on with them, but they're constantly reopening it to fix and tweak it because they didn't get it right the first time. But section 5 of the permit is the monitoring requirements. As such, I'm going to go over all the monitoring requirements, but the first big one that we're going to go over is the sampling time. There are 2 seasons in which I'm required to sample. There's the summer season, which goes from June 1 to October 31st. And then we have our winter season from November 1st to May 31st. Now the summer season, monsoon season, June through August, pretty simple. When we start going past August into September, and this has been a wet October, the storms are a little different and they're not as intense. They're more like winter ones, but we can collect a sample. It's really hard to by that point. So we really try to collect the sample in the summer season as early as possible. In the winter season, those storms, we can pretty much predict when they're coming in. We can definitely see them weeks in advance. Usually, by the way, the weather people are very apt to predict weather patterns during the winter season. And so we know the intensity of those storms coming in. And so we try to stage ourselves through those winter seasons to collect the sample, but sometimes they're very hard. When I go over the sites, we have one site in Flagstaff, and Flagstaff tends to get snow. So we tend to have issues collecting samples at that one during the winter season. And then we have to wait till later in the season, more in the spring. And that's a hit or miss, depending upon the winter season. But we're only required to collect 1 sample per season. I'm not collecting 3 or 4. I'm not collecting every time it rains. I'm only collecting 1 sample, recording the information, and then submitting the information to ADEQ. And that's it. So when we look at the results, I'll talk a little bit more about that later, but when we look at our results, that's only just 1 sample per season over a time frame. And it's taken us a lot of time to get these results, to actually look at them and kind of have some idea of what to do with it and what we're actually seeing. All right. So next in our permit with the monitoring program is we have sampling locations. Now we have been sampling at these 5 roadway locations. Those are all the green stars for over 10 years now. They are Flagstaff, Sedona, Phoenix in the West Valley, Tucson, and Nogales. We have had 5 maintenance yard sites, and those are the yellow stars also through that time. Nogales, there's 2 sites in Superior. They're just across the street from one another. We have to count them as 2 separate entities. But they both discharge to the same river. So those two sites, then Roosevelt and Spring Creek. Now, Roosevelt and Spring Creek are considered historic because we've stopped sampling them in this permit, and that's because the permit allows us to do that. The thing about Roosevelt is that the water body up there, Lake Roosevelt, is impaired for mercury. And we do not produce mercury on our site. We don't have any applications that would have mercury. And so therefore, we don't really need to sample for mercury. They pretty much know where the mercury is coming from, and it's not coming from our sites. And Spring Creek is just a little rest stop for ADOT operations just outside of Sedona. And again, that one, we don't have any operations there. Now, we've also done several impaired waterway sites. We were looking at SR 85 at the Gila River. We were looking specifically for boron in that location. And then we had US 60 east of Superior, and we were looking for copper in that area. And basically what we found is we didn't find any boron over at the Gila River, but we did find copper in the Superior area, which makes sense because it's known for its copper. So with that, though, we're really going to focus more on the roadway sampling in this presentation. And we're not going to focus so much on the yard stuff or the impaired sites, but I just wanted to go and let you know that we have data for all of this over the course of the past 10 years. All right. Now, when we talk about sampling, we have two types of sampling that we do. We have automated sampling, which is this complicated photo right here. And then we have grab samples, or just basically simple little fill up bottles. They look like little Nalgene bottles that we put at our yards. We're not required to do this type of automated sampling at the yard. So we just put bottles out, the water comes, they fill up, we collect them, we take them to the lab, and that's pretty much it. When we do our roadway, we do automated sampling because, one, there's large distance between Tucson and Phoenix to the outlying areas. And most of the consultants are usually located in Phoenix. So everybody mobs out of Phoenix. So we do that. Plus, there's data logging, there's notification requirements. There's a whole bunch of other things that just makes our life so much easier. And with that, the automated sampling, and the biggest advantage to it is that it does composite sampling. We're required, when we do the roadway sampling, to collect two types of samples: a composite sample, which is a sample over the storm column over time. So it's kind of like start, collect the sample, stop for a few, let so much pass, and then start again, and then stop, and then start again and stop. And basically we collect about 9 liters of that. We're also required to collect a grab sample, which we can do just by sticking a dipper under there and collecting as much as we need for the parameters that we're required for. So when we actually look at these roadway sites, we start over here at this silver cabinet. And I'm not too sure if you could see my cursor, but there's a silver cabinet over here on the left-hand side. These are standard roadway boxes that you see pretty much at every intersection all across the state of Arizona, pretty much everywhere. And if you've ever wanted to see inside of them, just look at the next 2 photos just to the right. That's what they look like inside. Now, the roadway ones actually have a lot of electronics and wires and stuff like that. These have actually been cleaned out, but they make great cabinets for our purpose. And the system is really nice because they're nice and secure. They're very hard to get into. So breaking into them by outside vandals or anything like that is just next to near impossible. One time we had to go up to a site, and I forgot my keys, and we tried to break into it, and we just could not figure it out. But they're equipped with a nice locking system. They're equipped with a solar panel on top, that white, small, slender white box with like rust on top of it. That's actually a solar panel up there because they're all being charged by solar panels. And then the tall pole at the very top, that's a rain gauge with a 100th of an inch accuracy. So that's our basic setup. Inside, like I said, we have 2 different types of systems inside. They're both essentially the same, but depending upon where they are in the state, Tucson and Phoenix both has the drum looking one on the bottom, while the outside locations, Flagstaff, Sedona, and Nogales, have the more boxier looking. And the only differences between them is that the boxier one is actually a refrigerator. So when the program starts and it's required to take a sample, it's already chilling down the sampler and getting it cold, so that when the sample gets in there, it's already starting the preservation process. In theory, the Phoenix ones, since most consultants are either located in Phoenix and Tucson, they can get there much, much faster. But due to rising temperatures, especially during the summer, we're going to have to move everything over to an avalanche system, the refrigerated kind, because it's just getting too hot, especially during the summer. So we want to make sure that sample is preserved. But what you can see, especially in that avalanche one on the top, you can see the box, the cooler, and the head, the dark gray piece. That's actually the sampling port. The water comes in to that and then gets pushed down into a bottle underneath there. And then the blue thing just off to the side of it, that's our modem. That's kind of like the brains of the project. That's the one that actually controls everything and helps to make sure that the process goes off, and then also sends out the signals so that we, the samplers, know when to go sample and whatnot, and we know what's going on at each individual site. So let's move over to the next set of photos. We have two types of systems where we actually sample from. This first picture is of the trench off the 202 in the West Valley. And this is in the P83 area off of Skunk Creek. It's an open trench. So an open trench is one of ADOT's wonderful ways to move stormwater. It's one of the trenches we can sample. In some other parts of the state, like most of them, the other areas, Nogales, Tucson, and Sedona and Flagstaff, we actually have culvert pipes, concrete pipes, corrugated pipes, whatnot. And that's what the bottom picture with the two probes sticking out from it, that's what that's representing. So we have two different types of systems which we actually monitor. And the system is set up so that we know how big those are, the diameters of them, their shapes, to all fit into the calculation, so we know when to sample. And then specifically with that bottom one, you can see a black box and a round cylinder, shiny instrument. The black box is actually our flow sensor. It actually sends out a Doppler radar and picks up the amount of water. It does two things. So it sends out a Doppler radar so that it knows dirty water is coming to it, because technically the water is not clean. No matter how clean clear water is, it's still not clean. I mean, it can pick up salt particles in clear water. That's how strong the Doppler is. But it's also a pressure sensor, so it detects the weight of water on top of it. So that gives it two types of systems to figure out that there's something there. It can, it's very interesting when, especially during the first point of the season, you get a heavy rainfall event and the sensor clogs up. You've got rain, you've got other stuff, you've got everything, you know something's going on, and you go out there and you go, oh, the damn thing got plugged up by some debris on top of it. It happens all the time, especially with that first flush. And the little silver thing next to it, that's actually a strainer. It's actually got several holes in it, and that takes you all the way out and throws it into the sampler, which is in the prior pictures. And then the final picture here, that's actually what we're sampling right there. That is water coming out of our Sedona site. That's actually at 179 right there at Oak Creek Canyon. The Tlaquepaque is just right off of this, and as you can see, we actually have water pouring out of that, and that's what we're sampling. And as you can see, it's not necessarily, it's clean, but it's not clear, and that's a perception issue, but that's what we're actually grabbing. That's what we're trying to find out. Why is it not clear, and what's in that? So when we actually do our sampling, they take the samples, they collect them, they're going to go send them to the lab. And these are the most of the constituents they're looking for. We need to know flow, we need to know pH, we need to know total dissolved solids, total suspended solids. We need to know our E. coli or fecal coliforms. We have a series of metals: arsenic, cadmium, lead, selenium, zinc. And then we have some inorganics and some nutrients. And then the final is the organic toxic pollutants with the PAHs and the total oil and grease. You know, if that car is leaking all over the place and dripping oil, we want to know that. In year 4 of our permit, we actually have an expanded list of stuff that we have to look at. And it's highly extensive. We'll be looking at different type of SVOCs, acids, bases, PCBs, and a whole bunch more pesticides and things like that. That's also in our water. So we have a very expanded list. This is our more routine list that we do year in, year out, and then year 4 we expand the list, and then we report that. Oh, the picture didn't show up as well as I was hoping. So a qualifying storm event. So there's 2 requirements to a qualifying storm event. We have to get 1/10 of an inch of rain or more and a measurable discharge. Now, the system that we use, the ISCO system that we use, can measure really low flows, but it really isn't effective till about 1 inch. So our measurable discharge has to be 1 inch for these systems. And when we get that, we get these beautiful graphs here over here. And I'm sorry the graph didn't show up as well, but I'll try to do my best to explain it. And hopefully you'll be able to see everything. It's funny because on my one screen, it's there, but on your screen, it's not. So we'll go ahead and describe it. So we got this blue line here, and this blue trending line is our rainfall over time. So as you can see, as the storm events, the first record is 1/100th of an inch of rain, and then over time it's exponential. So the rainfall is accumulated. But the actual here, the orange line, the actual flow in the storm drain doesn't occur till sometime later. You have to get a whole bunch of rain to fall. It has to start saturating the area. And then once it saturates the area, then you have overland flow into your drains. And then you have the drains finally taking that discharge and moving it out. And so we have a storm starting here about 20-100 hours. About 20-30 hours, we finally get some type of flow. And then as we get flow, the flow starts to accumulate over time and then tops off and then levels back out. So you get this nice, beautiful stair diagram. Well, this flow is the first flush. This is what we're trying to capture. And these black dots down here represent the alquats we do over the flow proportional composite sample. There's 30 of them there. That gives us about 9 liters. And that gives us our sample. And then what you don't see here is this arrow is pointing to the blue area, but there's actually a shaded area. And that area is the area under the curve, which is what we're trying to capture. And so we have rainfall at 1/10 of an inch and at about 1 inch of flow. And that corresponds to approximately the first black dot that the system turned on and said, hey, I'm ready, I'm awake, I got my 1/10 of an inch of rain, I got my 1 inch of flow, I'm ready to go. And then sure enough, it did what it was supposed to. And this represents to us, this is a perfect set of samples. And then from there, we just move on and record this and hold on to it and go, yay, we got what we needed. Everything was done in one sampling event. Oh, there it is. That showed up. Okay. So so there's the area under the curve, and there's the markers that show 1/10 of an inch of rainfall and measurable discharge of 1 inch. Okay, so our next section of this is, so we do all this work, we get results, we send them in, we get results, we look at them, but what does it mean? So we need to compare our results that we get to some type of standards. And the first one we always compare it to is Arizona Department of Environmental Quality Surface Water Quality Standards. And are we low or are we high? And we have to look at those numbers and we have to compare our results. And then from there, we need to report to them whether we're high or low. But for this particular project, we decided, well, okay, so we're comparing to ADEQ, which is great. We know if we're exceeding our requirements or if we're below our requirements. But what does this really mean in the general realm of things? I mean, how does this compare to others? Luckily, other DOTs across the nation have been doing this too for a very long time. And the Federal Highway Administration has helped with creating and gathering this data. So they hired the USGS to basically create this highway runoff database. And from there, the database has gotten information from various places such as the Federal Highway Administration, California, Massachusetts, Michigan, Texas, Washington, Wisconsin, and conglomerated all in this database. And so you can search this database for your parameter. Let's say you want to look at lead, which is one of the ones we'll be looking at momentarily. And you can look at lead and you can see where the results are across the nation. And then you can compare them. So that's a good thing. But the nation is 50 states, various regions, cold regions, wet regions, dry regions. So how does that really work? Well, the next part is that we can compare our information to the city of Phoenix. The city of Phoenix has been doing the data for 10 plus years, just as much as we have. And so they have a series, they have a whole bunch of information too. There's a group of us called the Phase Ones. It's Phoenix, Tempe, Mesa, Glendale, Pima County, City of Tucson, and then of course ADOT. And so we've all been doing this for a long time. And City of Phoenix is just one of the many cities that we could have compared data to. And at the time of the prepared report, we took their data and looked at that. So now we're actually going to go into the data. And the first one we're going to look at is zinc. But before I go into talking about zinc and the levels, everything, I just want to set up the slides because we'll see these over the next couple slides. The slides start off with the first column is arid, mesic, and semi-arid, and that refers to ecoregions of the U.S. When I was talking about that database with all the DOTs across the nation, it goes into that database, but you have to code it to an ecoregion. So luckily, Arizona is a very diverse state. And we also have ecoregions that are very close in relation to those ecoregions. Arid, for instance, is less than 10 inches of rain a year. Well, that's Phoenix. That's Phoenix all the way out to Yuma. And then mesic is about 10 to 15 inches of rain a year. Well, that's Tucson, Nogales. And then there's, mesic is actually higher, 15 plus. So that's your Sedona and Flagstaff, while semi-arid is about 10 to 15 inches of rain a year. That's Tucson and Nogales. Then the next column is the average US. So it's those three columns just averaged out. The next one is Arizona urban, which is of course our city data. And then finally ADOT. So what are we seeing in this? Well, zinc is ubiquitous. It's all over the place. It's not only produced to protect and coat metal to help it from corrosion. It's used in metalworking. It's used in a lot of different processes. So your car is traveling down the street, it's getting wet, it's not rusting because the zinc is protecting it. Well, that zinc ultimately sheds off. And it can be found in the air and through atmospheric depositions. Fires can produce it, of course. Industrial operations can produce it. So zinc is ubiquitous all over the place. And what we're seeing here is that you look throughout the nation, ADOT is no different than anyone else. We're all about the same range, 250 to 300 micrograms per liter. So we're all about the same. But the best part about this is that the ADEQ surface water quality standards are 28,000 micrograms per liter. We are so low, factors low, that it's not a concern. We don't have to really worry about it. We monitor for it, but we're never ever probably going to see a situation where that zinc really is contaminating our environment, and we have to do something about it. It's present, but it's not really something that we need to worry about. So we're doing really good with that. Lead, on the other hand, is a little different. Lead is all over the place. Lead acid batteries. They're not so much in cars anymore, aside from the lead acid battery. As we switch to more electric cars, that lead acid will go away, but it's present in other forms. Lead can come in multiple different ways and discharge into the roadway, and I would think it's probably more due to leaded gasoline in older areas and old right-of-ways, that when we had lead in the gasoline, it gets deposited on the right-of-way. It just, because lead's heavy, it'll fall, it'll just probably stay at the side of the roadway. Arizona highways are more modern, so they didn't really have to deal with a lot of that. They've been rebuilt over the years, so there isn't a lot of that going on. But vehicle transport of equipment and supplies, so probably tractor trailers and transportation of loads of lead or contaminated soils on our highway is a potential source for lead in our waterways coming off of the ADOT right-of-way. And so what we're seeing here is that while we do have lead, we are lower than the Arizona urban or the average US. And what I think is going on in this, however, I'm not 100% certain, is that you look at the MESIC totals, that's pretty high. When you look at the MESIC, what I'm thinking is that those are probably the higher, those are probably the northern environments in the study. And those probably are older cities in which lead was probably more used. They haven't had a major turnovers of their freeways or various things like that. There's still more potential contamination sources in their environment already. And so that's probably why the MESIC is pretty high. But it's interesting that the arid and semi-arid is also pretty high, while ours is pretty low. And the only thing I can give for that is that our transportation system is much younger and more recently developed versus developed during that time period where leaded gasoline was still in effect. The bad thing, though, is that this ADQ surface water quality standards are 15 micrograms per liter, which is about that line. And since it's being a logarithmic scale, and so we're exceeding it. Now, what we've come to learn is that it's particularly ADOT's information is actually an average of all 5 sites. So over all 5 sites over time. And while we don't exceed them at the majority of sites, there is one site in particular that has had lead issues over the years, and we're not exactly too sure why. And we've never been able to find out why, because we've not had time to research it. It'll start, it'll stop. We'll start to get a program ready to do something, and then it's gone for a while, and then it'll come back. And so it's been an ongoing issue, but it's particularly one site that's causing our exceedances. If I were to break it out per 5 sites, you would see one site, and then the rest would actually be lower. Our next one is copper. Copper is ubiquitous in our environment. It's one of our 5 C's. It's in our state flag. I mean, copper is very important. Like I said earlier, we're monitoring in Superior, and we're monitoring for copper, and it's there. We monitor just outside of Superior on the US 60, and it's there. So copper is ubiquitous, and this graph definitely shows that. Now, when we compare everything, we look at the average US and we look at ADOT, we're about the same. That's probably about right. Again, copper is also ubiquitous in cars, especially as we're getting more and more electronic cars, the Teslas of the world and all those other type of electronic cars. They require so much copper. They get into a wreck, that copper is going to shed. The transportation of copper on our highways is all over the place too. But the Arizona urban, I think, is actually really interesting at this point, is that the urban environment has more contact points, more points where in the system that there is potential for copper to be introduced into the stormwater. And I think that's why you're seeing the spike in the Arizona urban versus the other stuff, because on the roadway, unless it's wrecked and somehow discarded all over the place, and even then it would have to get into really small fine particles. Aside from atmospheric deposition, it's just not something that we're seeing in the waterway. But the urban environment, there's way more potential points of contact. And of course, our surface water quality standards is 500 micrograms per liter. And again, we're sitting around 80 micrograms per liter, so we're way below that. And so we're in the safe zone in relation to surface water quality standards. Total nitrogen and total phosphorus. ADOT does not apply nitrogen and phosphorus past the actual construction, post-construction. So we put in do the construction site. If there is plantings, they get nitrogen and other types of fertilizer at that point. Beyond that, there's no additional fertilizers or anything that we put down. So there is no potential for long-term total nitrogen or total phosphorus in our system. However, when looking at this, we do have total nitrogen as one of our contaminants, and it is present, and that's only because the surrounding area. We cannot completely, at the time when we were doing this, we had one site that was near a park, and so that park, of course, gets fertilizers and grass cuttings and things like that. And so that stuff does shed, and it does get into our right of way. And it was an urban environment. It wasn't specifically taking the runoff from just the roadway environment. And so that's probably why we have the higher level here, but we're still lower than everybody else in the nation, all the other DOTs. I don't know if it's because they apply fertilizers or if they don't, or whatnot, but it's a good thing that we're low. Now, comparing it to the Arizona urban, again, more contact points. The city of Phoenix has definitely a lot more places where people, especially now, you want your winter rye to come in, so you're going to apply your fertilizer. So there's basically 2 big time periods throughout the year that you're applying fertilizers on grasses and trying to keep those grasses alive and grow and make them nice and pretty and green, plus parks and whatnot. So you have those contact points. So this clearly makes sense to us. And it's nice that our ADOT concentration is really low. And then when we look at our surface water quality standards, we're talking 10 milligrams. We're sitting about 2 milligrams per liter. So we're way below the limit on that. The next one we look at is total suspended solids. That's what gives you your color of water. And then total dissolved solids. You can't really see them, but think of it as salt in water when you make pasta. So with the total suspended solids, we're looking at more compounds that can cause a discoloration that you can see a little bit more. That would be organic materials, that would be soil particles, anything that can cause some type of sedimentation in the water column. And as you can see here, we're a little high than everybody else, but it makes sense because we're in an arid environment. In fact, if you look at the arid environment on the far left of the screen, you'll see that that's a little bit higher too for both of them, because arid environments, the soils don't have a lot of vegetation on them, and what soils are on there are highly erodible. And so that makes sense for both the Arizona urban and the ADOT right away. Now the TDS, where we see a lot more TDS is definitely in the winter and in the northern environments than in the southern environments, because the TDS, we do apply salt to our roadways in Flagstaff, basically along the I-40 corridor between Kingman to Winslow, through that area, and there's several other spots. And then of course this I-17 too. So we tend to salt and put down abrasives, and so that tends to add to the TDS in our waterways. And so our northern environments pretty much create this situation where we have a higher level of TDS. And then when we compare the water quality standards, we actually have to compare it to the EPA, because in this case, the ADQ does not have a water quality standard for total dissolved solids. And we're sitting at 500 micrograms per liter. And currently we're below that. Our next one we're going to look at is E. coli. Now, E. coli, this is a fun one because this is a grab sample. So we've gone through, and all the ones that we've talked about up until now have been the composite sample. That's using the equipment that we use. This is the sampler is going out there and grabbing a sample, putting it in a vial, and then putting it on ice right away. The problem with that is that E. coli has a hold time of 8 hours. 6 to 8 hours. And when you're sampling a storm event, we all know storms tend to come at 5 o'clock at night. Well, the labs aren't open at 6 or 7 o'clock at night, especially when you're in Flagstaff and you have to get them down to Phoenix, or you're in Nogales and you have to get them to Tucson. There's pretty much only 2 sets of labs we can use, and that's in the Phoenix and Tucson markets. And so you grab those samples and you get them down to the labs, and sometimes they do have E. coli. But as we've gone through and just tried to clean up the data as much as possible, we find that really, while we have E. coli, the E. coli is really low and compared to the Arizona urban. Now, I don't know why the other DOTs across the nation aren't measuring for E. coli. I'm assuming they are, and the results aren't in there because of the fact that it takes a long time to sometimes get to the lab, because sometimes you're sampling in the middle of nowhere. And so there could be that issue and too much data variability, and therefore not in the database. I'm not exactly too sure. I'm just speculating, but when we look at the Arizona urban, of course, more contact points, more points where E. coli can be introduced into the system, and therefore their numbers are much higher. Now, we recently have done a study that is coming out soon, and I'm hoping to have more information on that and another presentation on that, specifically talking about, for instance, E. coli. And what we are finding is that the E. coli is not human caused, it's transient animal caused. Your javelina, your coyote, your birds, squirrels, cats, anything that can live in the right of way, that's an animal that can live in the right of way or die in the right of way, like falcons eating pigeons and discarding their carcasses all over the place. I'm sure some people have had that in their yards. And so you get this material, and that decaying flesh has E. coli. It rains, it gets in your stormwater. Now you have an E. coli sample. So it's not my favorites of all the sampling. I like the metals. I like the other stuff. Give me whatever else. E. coli, I don't have people living in my right of way. I don't think that this is a concern for us. And as you can see, the surface water quality standards is 235 for most probable number per 1,000 milliliters. And we are exceeding that. That's why it's red. We are exceeding it. But again, it's not caused by humans. It's not caused by us. We don't have treatment plants in our right of way that are discharging this. It's not human caused. It's caused by other sources that we cannot control. And then finally, our last is, and I know this is really complicated, but when you look at PAHs, it's a series of compounds. And when you look at them, what we were able to do here is look at the compound and compare it to the DOT database, and then compare it to ADOT. And what we're seeing here is that while ADOT's not exceeding for anything too much, we do have some high numbers in some of the benzo K fluoroethane, and then there's a dibenzo AH anthracene. Our numbers are overall really low, and while in the database the average of all the DOTs, there's numbers that are exceeding 2, 3, 4. Not exactly too sure what's going on there. We're not seeing a lot of oil and oil residuals in our discharges. And I'm not saying that there isn't oil on the freeway. It's just we're not seeing it. So either that's getting picked up in the system, or they're just it's getting so dilute, the solution to pollution dilution, that's being so dilute in the stormwater that it's very hard to pick up. And that's the only thing that we could think about that's going on here. All right, so next comes our conclusions and pretty much the end of our conversation here. But what I want to talk about with this conclusion is bring up 3 separate areas. And again, this was a very high level 30,000 foot overview of looking at the data that we've had for 10 plus years and trying to figure out, what does this mean? Normally, when you do sampling, you're going to do 3, 5, 10 samples over the course of the season so that you're getting so you can take all that and then you can average it out and you get this great number over the course of a season. I take 1 sample each season and I have 2 seasons. And so when you look at that 1 sample, basically 2 samples a year, what does that really mean? And the data in the summer can be very different than the data in the winter. What does that really mean? So looking at it from a very high lens, what are we seeing? What's going on? That's what this was about. So from that, what we've been able to figure out, though, is that we're on par with other DOTs and that we pretty much we're consistent. Our information is relatively consistent. Our sampling is relatively consistent with other DOTs across the nation. But there is further research that we need to do to identify why we're seeing some of these things. For instance, the nitrate or the lead. Why are we seeing them? What is the direct cause of that? And when we get chances, we've done that. There's actually, like I said, a research project that we just finished up. And one of the specific points that we talked about was E. coli. There were a few others, and I'm hoping to bring that to you guys if you'd be interested in that in the next year. And so we're trying to do these other research projects to make sure that we are trying to identify the sources so that we can stop them and keep our water as clean as possible. And then finally, once we started really going through this process, we started to just ask some other additional questions of, are we sampling in the right places? Well, we actually had to move a sampling location in Flagstaff because it was, while we could get some samples, we couldn't get other samples at other times of the year. And so it was really hard to sample at that location. Plus it was in the middle of downtown Flagstaff, which was just really hard to get to, and it just did not serve our purposes. Well, we found a better location that serves and just collects runoff from ADOT. So now we're getting better results because now we're just getting ADOT runoff. And back when all this was put in place by ADEQ and ADOT over 10 years ago, sites were selected, but they weren't necessarily, they were vetted, but the way the vetting process went, probably there needs to be some revamping to that in today's line. We know that Nogales, for instance, is a small issue, and we would like to look at another location. Even Tucson isn't perfect, but the only one that is pretty much the Phoenix site. Next, are we looking for the right things? We're in a permit that's basically equal to the city of Phoenix, city of Tucson, Pima County, and the other jurisdictions, other large phase 1 jurisdictions. But we're a DOT. We don't have the contact points that they have. We don't have the industrial process. We don't have the commercial. We don't have the residential. We don't have the parks. We don't have that kind of stuff. So why are we using a permit that is completely dependent on the same things that a city is to look at? If our stuff is just moving people from one place to another, maybe we should be looking at other things. I'm not saying oil and grease isn't the right thing to look at, and certain metals aren't, but is nitrogen really the appropriate thing to look for? Is maybe looking at such things as 6-PPD, which is one of the new emerging contaminants. Maybe that might be better to look at. I do know that coming up here when PFAS becomes an even bigger issue than it already is, we're going to be looking at that because they are going to change the permits with respects to that. And so we're going to be lumped in with that, and we're going to have to do stuff about it. May or may not be a good thing, but we'll see. And then finally, are we using the right regulatory program? While we are using the phase 1 program, again, we're a transportation agency. We just don't have certain things that cities and towns have. We technically don't have certain rights. We can't make rules and regulations. If we want to, we have to go to the legislature, and that's a interesting process that I do not want to ever go through again. So it's not very easy to handle, and it's not very easy to work with. So maybe we need to look at our permits differently for transportation agencies versus looking at us as through a lens of a city operation. I do understand that the DEQs of the world, or the EPAs, don't really understand transportation, but transportation actually does have people at the EPA that they pay for, that all DOTs pay for. And so we can get those types of programs. It's just there doesn't seem to be any movement because we're small potatoes. You know, there's just 50 of us across the nation versus the other municipalities and the other things. And nobody wants to go back in and go clean up the regulations anyways, because that would just be a mess, especially in today's political environment. So there's issues with that, but we're working through them and we're trying to make it better. Like I said earlier on, ADQ has now reopened our permit again, and as the public, you guys are free to comment on that if you wish. And with that, that is my program. That is my monitoring program. And if you do have any questions, please let me know. And there's my contact information.
Thank you, David. Does anybody have any questions? One thing, I think I thought it was very cool that you have taken personal ownership of all the highways and you refer to them as my highways.
Yeah, well, it's I don't mean it as in mine. I just mean it. It's just yeah.
So what options would ADOT have if one of the contaminants you were monitoring for did skyrocket on a consistent level? Like, what can you do? Because as you pointed out, it's like everything is running onto your roadways and things really that aren't of your control, other than, you know, the roadway surface itself. How would you go about trying to reduce something like that?
So after we get our results back, we are supposed to look at them and then say, oh, we're exceeding here. My consultant then goes out and is supposed to do an investigation to try to determine why we're having an exceedance. Since it's something like E. coli, which we always exceed on, we just don't worry about it because there's no sense in following up on that.
Mm-hmm.
But if it was something else, like lead, like I said, we've been trying to get a project together, but then every time we start, it goes away. And the only thing we could think is that there is an operation that is off the road, that is discharging onto the road, that is getting into the storm drain system, and then we're picking it up. So it's just like it's episodic operation that comes in, oh, lost money, didn't make profit, so now it's shut down, so now they're not doing anything. Every once in a while they open up or somebody comes into that location. So, but the problem is that we don't have, we're not constantly doing it because we don't have we don't see a lot of exceedances. We pretty much see the same every time. But when something does crop up, we go out and we try to investigate and we try to figure it out as to why we're seeing it. There's research being done. I've heard, I saw a presentation on this. There's research being done to figure out some of the E. coli stuff. And while I say yes, we feel that the E. coli is from transient, there's theories out there that even some of the E. coli may be because the pipes themselves have growths in them of vegetated microbiological forests in them, and they may produce some of that stuff. And so that could be one of the reasons why. So I do know that in San Diego, they are trying to figure out what's in the pipes. Is there like a biofilm or some type of something that's in the pipes that could be also contributing something to the stormwater sampling, and that you would see that. And if that is the case, then yeah, that would be something that we would have to, I don't know how we'd be able to quantify it and be able to go, oh yeah, it's just a biofilm that we have back there. I do know that in Sedona, though, that pipe we saw in Sedona actually discharging, if you follow that back, if you were to actually crawl back there, which I do not recommend you do, you would actually crawl back to a cistern. And in that cistern, the city of Sedona is required to clean it out. Well, it fills up with trash so that we don't get trash in the discharge. But as you saw there in that photo, there were clippings of vegetative. And while it picks up the trash, it doesn't always pick up all the organic. And when they vacuum it out, they don't clean it 100%. I mean, they don't bleach it. They don't make that thing where you can eat off of it. In fact, you don't want to. So obviously there is something there, and that could be one of the reasons why we have E. coli in our Sedona sample.
Interesting. Thank you. Does anybody else have any questions? Everybody is quiet.
Yeah. Like I said, this is just one piece of our program. You can go on, I don't have it open at the moment, I don't think. I'll throw it in the chat if I can find it here real quick. Nope, that's not what I want. This one. There is a public notice right now. ADQ is, like I said, reopened all of them, and you can go and post, view each one of these public documents. All the cities, Glendale, Phoenix, Pima County, Scottsdale, Tempe, and Tucson, plus ADOT has open public notices right now. So you can actually go see what our permit states. And if you wish, you can make a comment about it. We all pretty much say the same thing. Ours is a little different because technically we're a DOT and not a city, but they're all the same.
Mm-hmm.
We all have to sort of do the same thing.
All right. Well, thank you very much. I really enjoyed your presentation. And you had mentioned coming back again when you have some more information on your study.
If you guys wish. Yeah.
Yeah. Yeah. Thank you for coming. Thank you for your time.
No problem.
Last chance for questions. No.
All right.
Okay. Well, thank you very much, David, and thank you everybody else for joining us tonight.
Thank you, David.
Thanks, Dave.
All right. See you guys. Oh, David, you don't have to stick around if you don't want. And actually, if anybody would like to stick around and talk a little bit about the 2023 conference planning, for those of you who don't know. Thank you, David. For those of you who don't know, next year in May, the National Association of Environmental Professionals is going to be having their conference in Phoenix. And us local folks are going to be hosting that conference. And so we are participating in the planning process right now. And we've been having bi-weekly meetings with the national group to come up with field trips and identify speakers and sponsors and review abstracts. We've got abstracts that have been submitted. We have 106 abstracts that were submitted, which is pretty exciting, I think. Most of them looked pretty good at first glance. So yeah, if you want to stick around for a couple minutes, we don't have that much to go over. Most of our planning people, it looks like, aren't on here. And the rest of us just talked a week ago about it. So is Gerald still on? No, we lost Gerald. I was going to update her on a few things, but we can do that some other time. Does anybody have any questions as to what we're doing or the kind of the process that we're in? I will say in our meeting last week, our board meeting, we talked about deciding on our field trips that we're going to have by the end of October. We have 4 or 5 locations that we've been talking about. We need to kind of solidify those and come up with a solid list for national. There's a couple other items we had on our list. I don't have that notebook in front of me that we need to finish up by the end of October. And the abstracts review are going to be starting here pretty quickly. Our local committee had a chance to look at those abstracts, and especially the local abstracts, to see if there's anything that we really didn't think was appropriate. It was our chance to kind of highlight those. And yeah, you guys have anything you want to talk about? Susie or Nick or David?
So
Just
how,
sorry, go ahead, David.
I think we need to figure out how we're going to actually nail down make the final decision on the field trips and the other. I'm trying to remember what the other thing was that they wanted to have done by the end of this month. I can't remember what it was.
Yeah, I guess I don't have that notebook in front of me. I think I do. I think it was this notebook. There are a couple things.
I'm gonna pull it up in the Google Docs.
Different notebook. Is it keynote speakers or lunch speakers?
Possibly. I don't know why. I don't understand why I can't find my notes from that. I don't know. I'll have to hunt around some more.
Yeah. We have a meeting next Tuesday with the national folks again, I believe. So we can circle back to that. Oh, wait, end of October? We're supposed to, I don't know why October has gotten away from me so badly, but it's almost over. I was thinking we had like another 2 weeks to make these decisions, but we don't. We've got like 1 week. No, okay. I'll go find my notes and see if we can make some decisions on these field trips.
I think I'm looking at the email that I'd sent out. Maybe I put all that stuff in the board of directors, but I think the biggest thing was we had said we had said the field trips by the end of November.
Oh, November. That's better.
And then I think we're still waiting on the prospectus, so that's, we don't have that yet. I think the nailing down the field trips and then I don't know what else we want to do with the abstracts. I saw maybe 3 that are, I thought, I'm not sure if this is what we want or not, but we could discuss those. We don't have to discuss them tonight, but
Yeah.
you know, I know the technical committee will take on the heavier lift there. So anyway,
Yeah, Donna had sent me her list and she had a handful of them on there. A couple of the same ones that I had flagged, and a couple other ones.
I
But
put my
most of them,
drive with just yellow on the highlight. I highlighted them in yellow. They were like,
yeah. Yeah. If you want to send that to me, I'll compile it into one spreadsheet.
okay. Maybe next Tuesday we can revisit the field trips collectively.
Yes. I'll admit there's been a lot of emails back and forth regarding some of the cultural trips. And I think I've kind of lost track of them a little bit.
You're not the only one.
Okay. Is there anything anybody wants to bring up, whether it's conference related or not?
Only update on my end. I did talk to Jill Grams about a contact at NAU, and she passed along some info to me for the professor that she worked with when she was doing some NEBA trainings there. So I don't know if we have one person designated to contact those people, or if you want me to reach out to them, or have Jill reach out to them with some of that sponsorship info.
Yeah, why don't we wait to reach out for sponsors until we get the updated prospectus from National, just so we have something.
Oh, I thought they had
solid to
finished
put
that.
in
Sorry.
I don't think they have. I think it's still in, well, I don't think it was even what I saw was in draft form. It's last year's that she sent out.
Yeah, you're right. That's the only one
Yeah.
I've seen.
So as soon as
Okay.
she sends that out, we can have something a little bit more solid to put in front of people.
I see. All right. Well, I can add them. I think we've got the spreadsheet. Is that on here? If I can't find the spreadsheet, I'll just email it to y'all to add to that.
Okay.
Oh, here we go. Sponsors. Okay, I got it. Thanks.
Cool. All right. Well, thank you all for joining us. Hope you enjoy the rest of your evening.
Thank you.
All right. Good night, everybody.
Night, guys.
Night.
Bye-bye.